Hello class, Math 1440. Today we're going to look at two problems from section 6.4. Here's the first one. Find the area of the region under the graph of f of x equals 2x on the closed interval 1 to 3. That means x equals 1 to x equals 3. Using the FTC, Fundamental Theorem of Calculus. And then we want to verify our result using geometry. So whenever you're asked to find the area of the region under a curve, that means we want to do the definite integral. So I start off by writing the area, A stands for area. Area is equal to the definite integral from x equals 1 to x equals 3 of our function 2x dx. And I pulled out the constant factor of 2 on the other side of the integral. That's a property of integrals. You're allowed to pull out constant factors, not variable factors, just constant number factors. So it's the same thing as saying 2 times the integral from 1 to 3 of x dx. And now to evaluate this integral, I'm going to use the power rule of integration. I do not need a u substitution for this integral. This is just going to be one of those straightforward power rules of integration, where you increase the power by 1 and then divide by that same number. And don't write plus c with definite integrals. We're going to get a number answer. Definite integrals always give you a number answer, and that number will be the area under the curve from x equals 1 to x equals 3. Okay, so my brother is going to continue taping me as I progress with this problem. Okay. Hello, class. Here is back to my brother. Okay, so we got 2 times this definite integral. So I'm going to use the power rule. So once I apply the power rule of integration, I'm going to drop these symbols. So keep that 2, that's part of our answer, times, and then the integral of x dx is going to be x to the second over 2. Once you get your definite integral, then you draw the evaluation bar, and we're going to evaluate from x equals 1 to x equals 3. Equals. Here the 2's cancel, so if you can simplify, that makes life easier. So think of this as just x squared. So you always input the top limit first, the top limit of integration. So when x is equal to 3, 3 times 3 is 9. 3 squared is 9. And then it's always minus. You always subtract, and then you input the lower limit of integration. So when x is 1, 1 squared is still 1. So 9 minus 1 equals 8. You could write square units if you want, because they do say what's the area, but this is good enough. 8 is our final answer, or 8 square units. So we're done with that first problem, except we now want to use geometry. We'll get the same answer of 8. So let me do that now. I'm going to use a little geometry here. So typically on a calculus test, you don't have to know this geometry, but you never know. Okay, so here it is using geometry. I'm going to draw my Cartesian xy plane, and we're going from x equals 1 to x equals 3. And I want to graph the line y equals 2x. Well, when x is equal to 1, 2 times 1 is 2 for y. So 1, 2 is on this graph. Notice 1, 2 satisfies this function. That's why it's a point on the graph. When x is 1, y, f of x means y, is 2. And now let me get the other endpoint of this line. When x is 3, 2 times 3 is 6. So 3, 6 is about right there, we'll say. 3, 6. So on the y-axis, we went up 6. Okay, and then you just draw that line segment. You don't draw the whole line, because we're only interested in this line y equals 2x on this closed interval. Okay. So what's the area under the curve? So what you want to do is draw vertical lines from x equals 1 to x equals 3. So this is what they're asking. What is this area inside this closed region from x equals 1 to x equals 3? So here's one idea. I'm going to make this shape is a trapezoid actually, but to make it easier for myself, I'm going to draw a dotted line. So that way I get a right triangle on top of a rectangle, because these are right angles here. So I got a right triangle on top of a rectangle. So the total area is going to equal the area of the triangle, area of the right triangle, plus the area of the rectangle. And I guarantee you, When we add up these two small areas, getting the entire area, we will get 8 for our answer. So remember, area for any triangle is 1/2 base times height. The base is going to be, x is going from 1 to 3. So to find the length of this base, just go 3 minus 1, which is 2. So there's the base. And the height of this triangle, well, we're going to have to know what this point here is, because the height is going to be the tallness of the triangle. It's going to be the segment that goes from the highest point to the base. The base and the height always meet at a right triangle. So this height is going to equal, and what is the coordinates of this point? Clearly x is equal to 3. And what is y equal to? Well, this point has a y coordinate of 2. So y is equal to 2. This is y. So this point is x is 3, y is 2. So now to find the height, you want to subtract the y coordinates because the x's are the same. It's a vertical line. So subtract 6 minus 2 and you get 4. So that is the area of the triangle, 1/2 base times height plus the area of a rectangle. The area of a rectangle is just length times width. So we took care of that triangle. Now to take care of this rectangle, the base is going to be 3 minus 1, which is 2. And then the height, well, this point right here is x is 3, y is 0. So the height of this rectangle here, the x's are the same, just subtract the y coordinates. 2 minus 0 is 2. And again, I really don't think you're going to have to know this geometry approach for an exam, but it's nice to verify that this integral really does give you the area. It's comforting if we get 8 as our answer again. The calculus approach and the geometry approach. It's a happy marriage. Okay, so let's simplify this first term. Half of 2 is 1. And what's 1 times 4? 4 plus, and then 2 times 2 is 4. And 4 plus 4 equals 8 once again. So either way, geometry or calculus using integrals give you area, you get the same answer. Okay, we are done with that. Let's go to the final problem now. Find the area of the region. So area is given by a definite integral. Since our interval on x is -8 to 1, we're going to go from, whoops, I did this wrong here. Let me change this. You always go low to high. So it's going to be actually -8 to 1. So the area is going to be the definite integral from -8 to 1 of our function. And I simplified the cube root of x as x to the 1/3. So think of this as 1 minus x to the 1/3. Cube root means 1/3 power. So that's what I have here. 1 minus x to the 1/3 dx. Okay, so whenever you do a definite integral, the first step is just to find the indefinite integral. What is just this integral? 1 minus x to the 1/3. So I'll just do some scrap work here. So I just want to know 1 minus x to the 1/3. Whoops. Just the x is being raised to the 1/3. So whenever you're asked to find a definite integral, the first step is just to find an antiderivative, an indefinite integral. So the integral of a difference is the difference of the integral. So this is like saying the integral of 1 dx minus the integral of x to the 1/3 dx. Or more succinctly, what's the integral of 1 dx? It's just x. Because isn't the derivative of x back to 1? That's a good check. If you aren't sure if you did your integration right, do the derivative of your integral and you should get back to the original. So the integral of 1 dx is x minus, and for this integral of x to the 1/3 dx, once again, let's use the power rule. So you increase the power by 1. What is 1/3 plus 1? Think of 1 as 3/3. So 1/3 plus 1 is 4/3. Keep the common denominator. 4/3. And then you divide by 4/3.
That new number.
But instead of dividing by 4/3, I'm going to save time, because isn't dividing by 4/3 the same thing as multiplying by 3/4? So now that I have my antiderivative, then you recognize, oh, this is a definite integral. So we have to evaluate this from x equals -8 to x equals 1. Okay, and now to get our answer, we're going to first input the 1. You always do the top limit of integration first. When x is 1, I get 1 minus do this exponent first. What is, when x is 1, what's 1 to any power? It's 1. 3 times 1 is 3, and then over 4 for 3/4. So that's what I get when I input the 1. And then it's always going to be minus the expression. And now you input the lower limit of integration. When x is a negative 8, wherever I see x's, I'm going to write negative 8. So negative 8 for this x minus, and now it's going to be 3/4 times x to the 4/3. So let's first do x to the 4/3 when x is negative 8. So I'm going to do that over here. What is negative 8? Make sure you put in parentheses. It's all of negative 8 to the 4/3 power. Do the root first. Cube root. What's the cube root of negative 8? Negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. So you can take odd roots of negative numbers. You can't take even roots of negative numbers under the real number system. So the cube root of negative 8 is negative 2. Now we're going to take that whole answer, put it in parentheses, and raise it to the 4th power. So a negative to an even power is positive, and 2 to the 4th is 16. So I get 16. So now that I know that the answer is 16, don't forget we got to multiply it by 3 and then divide by 4. So I'll just do that over here. What's the 3 times the 16 and then divide by 4?
That all equals 12.
So one way you can do it is you can do the division first. 4 goes into 16 4 times. 3 times 4 is 12 for the answer. Or it could go 3 times 16. Simplify the numerator is 48. But what's 48 divided by 4? Is 12. Don't worry about it. So 12. So just write 12 here. And is that 12 gonna
I'll continue. You get the phone.
No, don't worry about the phone. Okay, so this is going to equal 1 minus 3/4 is 1/4, because 1 is like 4/4, minus the expression, negative 8 minus 12 is a negative 20. So this is going to equal 1/4 plus 20, which is equal to 20 and 1/4, but I don't know if that answer is right. Let's see if we can find any mistakes that I might have made. Because I thought the answer was going to be 18 and 1/4. This 1/4, let's see. Let's just look at that for a moment. I'm going to see any mistakes there. Let's see. We got the dog right here. Oh yeah, I see my mistake. Oh, actually, it's fine. On my notes, I had it from negative 8 to negative 1. That's okay. So from negative 8 to 1, everything is done correctly. Everything is done correctly. Okay, so we are done. So thank you, everyone. We are really close to the end now. We are really close to the end. This was 6.4. I believe we just have 6.5, and that might be the last section of the course, if I remember correctly. So test number 3 is going to be coming up maybe, it's either next week or the week after. It might be the week after or next week. Anyway, you can check that syllabus. Don't be afraid to check that syllabus periodically to know what's coming up. Okay, good night, everyone.